Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing protocol-independent routing, where we will review Junos routing features independent of dynamic protocols. In this lesson, we'll be covering the theory and configuration of static, aggregate, and generated routes in Junos. All three of these route types are administratively configured routes, though each of them fulfills a different purpose and use case. Let's start off by reviewing one you've probably seen before: static routes. A static route is an administratively defined route within the routing table. In some Juniper and other documentation, you might see the term Routing Information Base, or RIB. This is generally used as another term for the routing table. Static routes consist of a destination prefix and a next hop configuration. The next hop must be reachable for the route to appear in the routing table. If the next hop is not reachable, the route will be hidden. By reachable, we mean that the next hop must be an IP address that is either part of a directly connected interface route or can be resolved by the other routing information present in the routing table. If the next hop value is indirect, meaning the next hop is only reachable through another router that we're connected to, then this next hop must be resolved. As we see here, this route has a next hop which is not directly connected to the router we're configuring, though is reachable one hop away. Resolving the next hop means using the next hop of the active route, which includes the static route's next hop. By default, static routes have a preference value of 5. If you're coming from Cisco devices, the preference value serves the same purpose as administrative distance. This means that the preference value will determine which protocol's information will be installed in the routing table if multiple sources provide a route to the same prefix. A lower preference value is more preferred. Below, we can see that we use the command show route protocol static to show all active static routes that are in the routing table. In this example, we have a single static route for the 192.168.10.0/24 prefix with a next hop of 192.168.2.1. We see that the 2.1 IP address is reachable via the GE000.0 interface. The fact that this route is showing in the routing table as active means that the next hop is considered reachable. It's possible to also provide an additional next hop for the router to use in the event that the primary next hop becomes unreachable. This is called a qualified next hop. Let's see how we configure a static route in the next slide. At the bottom of the slide, we have our static route configuration. This configuration is done in the Edit Routing Options Static configuration hierarchy. In our configuration snippet, we have a route configured for the destination prefix of 192.168.10.0/24. We have the primary next hop configuration shown with the next hop configuration command. Here, we see that we have a qualified next hop configured, along with the preference value. We can see the effect of this configuration in the output above. We see in our output of show route protocol static that we have our entry for 192.168.10.0/24, which has two available next hops. The first is the primary next hop, which has the default preference value of 5. Then below, we have the qualified next hop with the configured preference value of 7. Now, a static route will appear in the routing table as long as the next hop is reachable. This may be used as an aggregate or summary type route, though doesn't take into account if the more specific route is reachable downstream, as we'll see in the following slides. If we wanted to have a summary route or aggregate route in the routing table, only when a more specific route within the range is also present, then we need to use what Junior aptly calls an aggregate route. Aggregate routes are also administratively and statically configured. They are a composite of more specific routes. As we have in our example towards the bottom of the slide, we see that these three routes can be summarized by the 10.0.0.0/20 aggregate prefix. When an aggregate route is configured, at least one contributing route must be present in the routing table for the aggregate route to appear. A contributing route is any subnet that is fully encompassed by the aggregate supernet configured. A shorter prefix or larger route, which either overlaps or fully encompasses the aggregate, will not be used as a contributing route. Only more specific or longer prefix routes will be used. This is often used in conjunction with dynamic routing protocols to generate summary routes to advertised into the protocol and to other neighbors. This can be used for many reasons, though a possible example would be to summarize several more specific routes to shield downstream neighbors from flapping routes. Even if two of these three contributing routes are flapping, that will not cause any changes to the presence of the aggregate route, and thus could limit the number of routing updates propagated to the other nodes within your network. It's important to note that the default preference value for aggregate routes is 130. As shown here, aggregate routes are configured under the Edit Routing Options Aggregate configuration hierarchy. In this example, we've also set a community value with the route, which can then be used in routing policies for additional configuration logic. We'll review communities further in the BGP section of this course. In the sample output below, we see the aggregate route in the routing table. The aggregate route has a next hop of reject. This means that if a more specific route with a valid next hop is not present, then the traffic will be dropped. This further conceptualizes the need for a more specific contributing route to be present for the aggregate route to be present. The aggregate route itself does not provide any routing capability. It is used as a tool for influencing downstream routing by advertising the aggregate summary prefix into other routing protocols. Since the aggregate route requires one or more contributing routes for it to appear in the routing table, let's take a look at the commands used to view those contributing routes and other properties of the aggregate route type. This example output is shown by using the show route detail operational mode command. For this example output, we narrowed down the output by using the route 10.22.33.0/24 exact modifier to the show route detail command. Here, we can see lots of information about our aggregate route. We see that the next hop type is to reject, and that the task or type is aggregate. The piece of information that I really want to draw your attention to, though, is at the bottom. Here, we have the contributing routes. In this case, we see the little 1 means that there is one singular contributing route. That route is displayed below that line. We have that the contributing route to this aggregate is the 10.22.33.1/32 route, which is a directly attached route. Any type of non-Martian route may be a contributing route to an aggregate. The contributing routes can be directly configured on the device or can be learned by dynamic protocols. And Martian routes we will review in a future lesson. Now that we know how to configure and monitor static and aggregate routes, let's review the last type of route in this lesson, generated routes. Generated routes and aggregate routes are often confused because they behave in very similar ways. They are both administratively configured and will both only be present in the routing table when more specific contributing routes are also present. The key difference between a generated route and an aggregate route is that the next hop of a generated route is an actual valid next hop IP address, rather than the reject action of the aggregate route. The next hop of the generated route is defined by the largest contributing route. That is, the contributing route with the shortest prefix length, or encompasses the largest amount of IP space. This route is the one which the next hop will be used as the next hop of the generated route. This also comes with a key caveat, which is that contributing routes for a generated route may not be directly attached. Where in the previous example of an aggregate route, the contributing route was a /32 directly attached route, that would not be a valid contributing route for a generated route. Contributing routes for a generated route must either be learned from a dynamic routing protocol or be configured as static routes. So let's see how we can configure a generated route and what it looks like in the routing table. Generated routes are configured under the Edit Routing Options Generate configuration hierarchy. As we see on the left, here we have a static route configured with a qualified next hop, and the generated route configuration appears below that. Notice that the generated route is a summary, which includes the 192.168.10.0/24 static route. Since the static route is included in the summary of the generated route will use it as a contributing route. On the right, we take a look at the generated route in the routing table. Notice that the generated route also shows as being from the protocol aggregate, even though it's a generated route and not an aggregate route. The route also has the same preference value as an aggregate route, 130. However, the key difference here, where you can immediately tell that this is not an aggregate route, is that the next hop is a real IP address and interface, rather than the reject action. The use case here would be slightly different than with an aggregate route. The generated route should be used when we want to actually forward traffic to the next hop of the primary contributing route, which is destined for an address outside of the specific contributing routes, but is within the aggregate route. Whereas the aggregate route will draw traffic towards the local router due to the route advertisements for the summary or aggregate route. Any traffic destined for an address not included in the specific contributing routes, but is included in the aggregate, will be dropped. Finally, let's review the detailed operational information of our generated route. You may notice that the output of the show route detail command for our generated route looks very similar to the output for the aggregate route. The task shown is aggregate, and there is a section for the contributing routes. The primary difference is in the next hop information once again. The next hop type is router, and the next hop is an IP address that is reachable over a particular interface, rather than the reject action. Thank you for walking through static, aggregate, and generated routes with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.